Shortly we will be building a larger pyramid. The advantage of this one is, well, it contains approximately 8,000 blocks, and it facilitates a more complicated internal architecture, and it will allow us to demonstrate how the blocks were raised to the higher levels and how some of the larger, heavier blocks, non-standard in dimensions, were raised into the upper reaches of the pyramid, especially the pyramidion block, which went right to the top. The other advantage of the larger pyramid is it allows us to section it and show the internal structures and also how all the blocks are put together. All of these models, of course, will be available. They can be supplied to order. Initially, we hope to build the bigger ones because they do show a lot more. They're far better at demonstrating the structure of the pyramid and how they were constructed. These also feature the light shafts. There were shafts that went from the burial chamber to the outer parts of the pyramid. These are all faithfully reproduced, and it's possible to shine laser lights down them and bounce them off and come through the opposite channel. Not strictly accurate, but good theatre. You know, the rocks you see in various parts of the States and around the world where there's limestone, they usually come in blocks. Sometimes they're quite thick, sometimes they're quite thin. And in between, they come apart, and that's because there are minerals inside that don't compress. And that mineral has plate-like qualities. And when it's mixed with water, it's very, very slippy. You ask anyone who has done pottery, who made pots, and you'll find that clay that they make pots with is very, very slippy. You get some on the floor and step on it, boy, you're in trouble. It's better than a banana skin. And I think that kind of a mineral would have been more effective at lubricating the passage of stone over stone than an oil or just water. Finally, I think none of the techniques that I've demonstrated here can be construed as eliminating any of the other systems that we know they use, such as dragging stones or hauling them on sleds. But my premise is that with a project of this size, the engineers would have based all their decisions on numbers, on how much, how long they had to do it, and not on qualitative considerations. What you do if you have to move one block is very different than if you're going to move 4,000 of them. I mean, for instance, some of the larger statues and later on the obelisks were floated down the river. They couldn't have lifted those stones onto boats. They would have had to have taken the stones over a dry dock with a ship underneath it and then flooded the dry dock and brought the ship up underneath the object and then floated it away by that means. But that would be not very efficient if you're moving thousands and thousands of blocks. It's okay if you've got one or two. You can take your time doing it. The same with building ramps and rollerways. It's only economic if you're going to use a lot of them. If you're only doing one or two, no, you just take your best shot and use as much care as you can.